Hey guys, it's Jeff here at Kuroki. Today we got a good chance to show you one of the projects we work on every day here. This is a replacement cylinder barrel for a case backhoe. Starting material is 47 inches long and it's 4 3/4 inch OD, 4 inch ID, pre-honed. The way these case cylinders are made is they will have an expanded bell end here, and they're made from a thinner wall tube that is formed so you have a step right here. That's something that we don't have a way to do. It would be done on a dedicated machine in production volumes. So we start with an oversized piece of tube and turn down the rest of it to suit. You don't have enough room to cut threads in the gland otherwise. What we've done here is a good example of how I like to do a lot of small jobs. Rather than doing up a full drawing for something that doesn't need it, we've done up a note list. So, target size, 46 1/4 overall length, 4 inches towards mouth end at 4.750 diameter, remainder of the length at 4.530, weld prep the small end of the tube, shorten by 3/4 of an inch, leave shortening allowance at mouth end. You need to pay attention with these when you're used to working with a list like this. It can end up saving you a lot of time of making unnecessary drawings for really simple parts. So basically what we've done here, we have it set up in a 3-jaw chuck and a pipe center. We've gone and set our, touched off our cutter at the end of the piece and then used a digital readout to dial out where the cut's going to stop. It's 42 1/4 inches from that end. Went and plunged in a little mark here so we have a positive reference. In this case, there's no way for it to move in a chuck, but it's just a habit I like to get into. It makes it harder for you to screw something up if you misread your DRO or don't set something right. It's just a visual reminder of where you're supposed to be. We've touched off in a diameter, zeroed our digital readout, and now what we're going to do is dial in our first cut and move along here. We have it running fairly conservative just because of how long apart this is. For doing a one-off job like this, I usually prefer to just take a lighter cut rather than having to set up follow rests and steady rests and such. It's just a more efficient use of our time. So we're running at 325 RPM and about a 7 thousandths per inch feed rate, which is quite low, but again, it's a long unsupported cut, so it helps you save having chatter and other issues. For the cutting tool, we are using a SNMG 432. This is a Kennametal in KCP 25C grade. You could use lots of inserts for this. You could use a Diamond DNMG, you could use a CNMG, you could use a TNMG. It really doesn't matter. The main reason I'm using this is because we do specifically have a tapered shoulder right here. So the lead angle of a 45-degree tool is not an issue. So may as well take advantage of the square inserts and a lower per edge cost anywhere you can. Without any more talking, I'm going to engage this and maybe take a couple of cuts on camera. I'm going to start with just a, well, we'll do a 100,000th cut for the first. And we'll see how it behaves. It might start chattering, and if it does, we'll have to adjust it a bit. That's something you run into a job shop work. You don't have everything proved out perfectly the way you do running CNCs. It's just a case of take your best guess and do something that's close enough, because the time you'll spend trying to optimize the setup is more than you're going to save by having a perfectly optimized setup. I'm not really loving the way this is chipping, or rather the lack of breaking chips. That's something you can kind of end up chasing your tail with on these. This pre-honed tubing is grade 1026 steel, and it's incredibly ductile and really hard to make it break a chip. So in the absence of anything too dangerous, we're just going to continue on with this unless we have a compelling reason to change. You do need to be really careful with these chips. You'll note using a chip hook to remove them. You never want to use your hand for that. I did in a moment of not thinking years ago and cut this fingertip off and had to have it reattached. So that's a good reminder not to do that. And actually looking at this, I am going to change to a different cutter here. I am going to change this out for probably a CNMG, maybe a DNMG. I'll see what I got loaded up in a tool here already. And we'll swap out to this one. And we're also going to bump our feed rate up. This is a TNMG insert. We're at a 10 thou feed rate now. So we're just going to retouch off again. This is just our initial roughing pass. So the exact diameter we're throwing really doesn't matter. So we're just going to pick up the cut where it is. And see how this one behaves. It's still not breaking a chip spectacularly, but we're at least not getting the long stringers, so this is something I can live with. And on this grade of material, you're never going to have perfect results. There's a few different things you can do to help promote chip breaking. The specific insert can make a big difference, the chip breaker geometry. The other things that can be factors are your feed rate, your RPM, and your depth of cut. Typically, if you need to promote chip breaking, you're going to increase your feed rate, you're going to increase your depth of cut, and you're going to decrease your RPM. You can use any one of those on their own or any combination of them together. And there are some cases where you just will not be able to get a chip to break, and that's where you get it as good as you can and you live with it, and that's just part of machining some days. See, it's not perfect, but it's leaving a nice finish. It isn't chattering. So we're going to leave it right like this, and there's no need to mess with this anymore for a one-off part. We're probably going to go ahead and call this video here. What I might do is pick up a second video once we get this machine down in the outside and flipped around. We're going to set it up in a steady rest, and maybe I'll try and get a little bit of a video about cutting the threads in the mouth where the gland screws in. Till then, thanks for watching, and we'll see you in the next video.